3 words that can make or break your shot peening process. If you're new to shot peening, getting a solid understanding of these 3 core elements, media, intensity, and coverage, will significantly contribute to your success in this field. While this presentation won't go into deep detail on each of these variables, the key message is clear: no matter your role, whether you're a part designer, machine technician, engineer, or foreman, it's essential that you take the initiative to thoroughly learn about them. There are various types of ferrous and non-ferrous media, each available in multiple sizes. Typically, the designer selects the appropriate media based on factors such as cost, durability, and the acceptable levels of contamination and dust generation. Media quality plays a crucial role in effective shot peening. For optimal results, the media should be consistent, predominantly round, and free from breakage. Using media with mixed shapes and sizes can lead to an uneven residual compressive layer, while broken media may damage the component surface. The media's size and type also directly influence peening intensity. Larger or harder media generally produce higher intensity. Additionally, media must be properly managed. Its flow rate should be controlled to fine-tune intensity, and care must be taken to prevent leakage or wastage, which can lead to machine downtime and increased costs. Build a strong, long-term partnership with a reliable media supplier. An experienced and trustworthy vendor can be an invaluable source of knowledge about media. Avoid switching suppliers frequently, as consistency is key. Invest in a high-quality media separator to ensure your machine consistently receives clean, properly sized media. Also, install a media flow controller to prevent media-related issues and maintain full control over your shot peening process. Intensity refers to the energy level of the shot stream and directly affects the compressive stress introduced into a component's surface. To determine intensity for specific machine settings, multiple Almen strips, typically 4 or more, are exposed to the shot stream, and a saturation curve is plotted. This curve shows the relationship between arc height and exposure time. The intensity is defined as the arc height at or near the knee of the saturation curve, where the rate of arc height increase begins to level off. This method is recognized and standardized. Refer to SAE 443 for details, and is the industry-accepted way to establish or verify intensity. Intensity is recorded as the arc height measured on a peened Almen strip using an Almen gauge. The induction of surface residual compressive stresses is a fundamental objective in the shot peening of metallic components, as these stresses significantly enhance resistance to fatigue failure and mitigate susceptibility to certain forms of stress corrosion cracking. Precise control and consistent attainment of peening intensity are critical to process reliability and repeatability. Intensity is influenced by a range of interdependent parameters including shot media size, material composition, angular impingement, shot velocity, and the progressive wear or degradation of key consumable components within the shot peening system. Importance of accurate saturation curve plotting in shot peening. Manual plotting of arc height data to generate a saturation curve can be time-consuming and prone to human error. To improve both accuracy and efficiency, use computerized saturation curve solvers, such as those developed by Dr. David Kirk, which automate the curve fitting process and reduce variability. Use of certified Almen strips. Always use certified Almen strips that are graded to help you easily choose the correct strip type, A, N, or C, for your application. Tested rigorously in both laboratory and field environments to ensure consistent performance across production lots. Avoid in-house manufactured strips. Do not use Almen strips made in-house. Strips must be free from residual stresses caused during manufacturing. Any such stress can skew arc height readings, resulting in inaccurate intensity evaluation. Understanding coverage in shot peening. Coverage refers to the percentage of the component's surface area impacted by shot peening dimples. It is quantified as a percentage. For example, 100% coverage means the entire surface has been impacted at least once. What controls coverage? Machine cycle time is the key variable used to control coverage. Achieving a specified level of coverage, for example, 100%, depends on peening intensity, determines the size of each dimple created by the shot. Media flow rate influences how quickly shot particles strike the surface. Material influence. Softer materials deform more easily, producing larger dimples, which means faster coverage rates. Harder materials require more time and energy to achieve the same level of coverage. Why coverage must be precisely controlled? Part designers and customers often specify an exact coverage requirement, aiming for just right coverage. Undercoverage may result in incomplete compressive stress distribution, especially in critical stress-bearing zones. This can compromise the fatigue performance of the component. Overcoverage can lead to surface damage, such as micro-cracking or cold work saturation. This increases the risk of early crack initiation and premature failure. Key principle: shot peening must deliver coverage that is sufficient to induce the desired compressive stress field without degrading the surface integrity of the component. Tools for accurate coverage verification. Traditional visual inspection methods for assessing coverage are often subjective, inconsistent, and prone to error. Coverage check tools provide a reliable and objective alternative, improving both the accuracy and repeatability of coverage evaluation. These tools help ensure that shot peening meets the specified coverage requirements, neither under nor over peened, with greater confidence and process control. Wrapping up: media, intensity and coverage, the core trio. By now, you've likely recognized that media, intensity, and coverage are closely interrelated. This presentation has covered the foundational knowledge essential for understanding these critical parameters. Feeling overwhelmed? Here's how to accelerate your learning. If the technical details seem daunting, you're not alone, and you don't have to navigate it all by yourself. Leverage vendor training. If you're involved in setting up shot peening in-house, you'll likely be responsible for overseeing the installation and commissioning of a shot peening machine. Your OEM, original equipment manufacturer, is a key resource. They offer detailed training sessions, comprehensive technical documentation, expert insights into media selection, intensity control, and coverage optimization. Make the most of every learning opportunity they provide. The more you understand your equipment and process, the more effective and reliable your peening results will be. Need help? We're here for you. In addition to this training, we offer ongoing technical support on all aspects of shot blasting and shot peening. Whether you need guidance on process optimization, media selection, intensity or coverage issues, equipment troubleshooting, our team is ready to assist you. Feel free to reach out for expert advice, audits, or hands-on support. Email bope@live.in. For more videos in future, subscribe to our channel https://www.youtube.com/channel/ucxdosu0hfwzrt_d2ff. Jizer.